Welcome to unit number 6. We are going to be studying solutions and solubility of substances this unit. So to start off with, we're going to just have an introduction to a lot of the terminology when it comes to solutions. Again, you've seen some of these words over the years in different grade levels and so forth. I touched on it earlier this year as well. So just kind of, again, just keep kind of using them, getting comfortable with what they mean. And yeah, just so when I'm using those words as well, you'll know what I'm talking about, okay? All right, so we're going to be looking at mixtures, a specific type of mixture in this unit. But there are a couple different mixtures that you would have learned back in elementary, early high school, where this is how matter breaks down, right? Pure substances, mixtures. So the pure substances are elements and compounds, which we've been studying a lot. And then, we've been reacting compounds together in reactions. And so anyway, we're going to analyze the homogeneous mixtures now, this unit. So whenever you have a couple components mixed together, you can't see the difference between them. They seem uniform. Okay, so that's why they call these a solution. So for example, if you take, salt and water, mix it together, the salt will dissolve in there and it still looks just like it's water. Okay, so we have a solution, a sodium chloride solution. Other examples, I'll usually call it a solution, but another term for it is homogeneous mixture. Okay, other examples of homogeneous mixtures or solutions are, if it's the air, if it's dry and clear, there's no smog or pollution in it, you wouldn't be able to see the difference between the carbon dioxide and the oxygen and the nitrogen in it. Okay, glucose solutions and IVs, same thing. It looks just like water. You can't tell that there's glucose and a mixture of water in it. Tap water, same thing. It looks transparent, colorless. But there are other elements in there that the treatment plant would have added, like chlorine and fluorine and so forth. Okay, all right. So that's what a solution is when you can't see the difference between the different components and you can't see different layers. The opposite is heterogeneous mixture. So this is when you can see different layers, like you have marbles and sand, or oil and water. Okay, the classroom air, if you or even there at home, you can see little dust particles in it and so forth. So that's a heterogeneous mixture because you can see the different components. And then, yeah, there's this little thing, like if you shine light through it, if you can see little things floating in there, then it's heterogeneous, but otherwise, if you can't, then it's homogeneous. Okay, so anyway, so we are looking at just the homogeneous mixtures, the mixtures where we shouldn't be able to see the difference in the layers and so forth. Okay, all right, so some other terminologies that we need to pick up here. So solution, so now you know what a solution is. It's made up of solute being mixed into a solvent. Okay, so the solute, you can think of, like, look at these examples here. You can think of it as like, the salt powder. Okay, or this is like copper 2 sulfate mixed it gets mixed into water here, and the water is the solvent. And then when they're mixed together, it makes a solution here. So I know it's blue, but you can't see the separate components in there, so that's why it's a solution. Okay. All right, so the one that there's more of is the solvent, and the lesser quantity is the solute. Okay, so because sometimes you'll mix liquids together and so forth, so don't always assume that the solvent is liquid. Okay, and sometimes you can have more than one solute though as well that makes up a solution, so keep that in mind as well. But yes, the one that there's greater quantity of is considered to be the solvent. And when we're studying a lot of examples in this unit, the solvent is generally going to be water. So here are some examples. All right, so like different things, like the glucose solution in IV. So basically, they'll take some glucose and mix it into water here. But there's a greater amount of water. So water is the solvent, glucose will be the solute. If we're looking at alcohol here, if they're described by the percentage of how much alcohol there is in it, 40% by volume of ethanol. So basically, you'll have 40 milliliters, out of 100, and the rest of it will be water, 60 mils. Okay, but water is the greater amount, it has the greater amount, so it's the solvent, and ethanol would be the solute. Okay, and then if you look at, you can get some alcohol, I think you go to the States and you get a higher percentage of ethanol in it, and so basically what happens in that case is out of 100 milliliters, 75 will be ethanol and 25 will be water. So in this case, ethanol is the solvent because that's the greater quantity. Okay, all right, so now that we're looking at, so now that we understand that something goes in solute, goes into the solvent and mixes up and makes a solution, we are going to look at, okay, well, does it, like if we add a little bit of solute or a lot of solute, how do we describe the different amounts, okay? All right, I'm going to use the word concentration a lot in this unit to describe the ratio of how much solute was dumped into the solvent and so forth. Okay, so a concentration can refer to how much solute compared to how much solvent, or it could be how much solute compared to the whole solution. Okay, so just keep that in mind. So usually, what we'll use is the how much solute we added for the volume of the whole solution. So the quantity might be the mass, might be the volume. Compared to the volume of the whole thing, the whole solution. All right, so if we have something that's concentrated, okay, so you're going to have a large quantity of solute compared to the whole solution, I guess, okay? So when you have a large quantity of solute dissolved in a certain amount of volume of solution, you have a concentrated solution. If you only have a little bit dissolved in a certain volume of solution, then it's dilute. So here's a visual example here. So we have the same, like for example, let's assume this is water, and say we dumped in, I don't know, some salt, okay? So this is considered to, the one on the right is considered to be the concentrated solution because there is a greater amount of solute that was dumped in, okay? So think of it as a large amount of salt was dumped in, where compared to this one, this is the dilute solution, you have the same amount of water, not as much salt or solute was dumped in here, okay? So that's why it's considered to be dilute. So what we're going to be doing a lot this unit is we'll take the a concentrated solution, okay, and then we'll water it down, okay, so that we can use it, usually it's cheaper for us labs in order to buy a concentrated solution from, the manufacturer, and then we'll, the supplier, and then we'll end up taking some pure water and diluting it and making a more dilute solution that we can use in our experiments and so forth, okay? All right, so, so just kind of get a good understanding of when I say this is concentrated compared to this one, or this one's more dilute, or you have to dilute this solution. Just understand that, visually, or just, be able to describe what's happening, okay? All right, to end off our terminology with solutions here, we're going to look at types of solutions that are we're going to study. So gaseous solutions. So I know, like here, we've been looking at a little things are in water, right? So that's what we'll do, a lot of things being in water, mixed in water, this unit. And then the next unit, we'll look at how gases are mixed together in solutions as well. Okay, so just make sure you understand that there's lots of different solutions out there. So gaseous, okay, made up of gas. So air is a solution, okay, a gaseous solution. Aqueous solution, so we've looked at that a lot. So whenever we've taken a substance and mixed it into water, we've always written AQ as the state symbol to show that it was a mixture. It was mixed in water, and so the solute was dissolved into water. Water is a solvent. Gasoline is an example. Salt water, right? Like barium hydroxide. We looked at lots of different ionic compounds that were mixed into water. All right, you can also get metal solutions. So you get a couple metals mixing together, and they call it an alloy, which is something maybe you're more familiar with, but it's a solution of two metals. So I know you're thinking, but it's not liquid. It's, like you could, heat it up, get into liquid, mix it thoroughly, and then let it cool down and harden. And then like we use it in jewelry and so forth, because for example, like gold isn't very is very malleable. It can bend easily, get scratched. So they'll mix it with other metals so that it can be, still nice, have a nice color, but it'll just hold up better and so forth. Okay. Um, so yes, you can have an alloy of metals. Okay, and an amalgam is whenever you have mercury as one of the metals. Okay, so mercury plus something else, is an amalgam. So just a specific name for mercury type substances here. So yeah, like they used to do this with dental fillings and so forth. Okay. All right, so that's an introduction to the terminology that you need to use. So just kind of keep referring back to here. If you're watching video and you're wondering, what did that mean? What does that mean? And so forth. Okay. All right, so we're going to move right into our first topic here, called concentration. Okay, so we looked at that already. It's describing how much solute there is in a solution. Okay, so volume of solution. So we're going to look at different types of concentrations. For the first one today is going to be amount concentration, and the units are moles per liter. Okay, and so those are the units. The letter that we're going to use is the little letter C. Other terms that chemists will use will be molar concentration or molarity. So just kind of all three of these. I would say like amount concentration is the IUPAC terminology that they use, but you'll find chemists will say molar concentration, molarity, and so forth instead. Okay, so just get comfortable with all three types of terms here. All right, on top of the units being mole per liter for IUPAC. So other chemists will use this old school way of naming the units and use the capital M. So just as you're going through and practicing today, just don't be thrown off if it's a capital M. You should know that it's the same as mole per liter. And if I say, find the molarity, then you know that I'm asking you to find amount concentration. So here is the new formula. Its amount concentration is equal to, see how it's mole per liter, so it's the amount in moles of the solute. Okay, so we're going to be still working with moles, and we're dividing by the volume of the solution, so the whole solution. Okay, and that has to be in liters, so there might be a lot of converting between milliliter and liter, so just make sure you can do that. Okay, here's just another term here, stock solution. So I talked about this already. So if we'll buy something that's considered to be a stock solution from the chemical company, and so then what we'll do is we'll buy that, and then we'll take a certain sample, water it down, and then use the lower concentration for experiments and so forth. Okay. All right. So just if I say stock solution, you should know what I'm talking about then. All right, so let's move on to an example here on how to has something related to amount concentration. I'm going to start off with using the formulas. I think there was a lot of people a little overwhelmed that I started off with the unit analysis last day, so I'll just start with the formula method, and then if the people that are using unit analysis method want to move forward in the video, you can do that. Okay. All right, so we have some sulfuric acid. It's a solution of hydrogen sulfate in water. Okay, so we're taking hydrogen sulfate and mixing it in water, and then we get sulfuric acid, or you can call it aqueous hydrogen sulfate. Okay, so both, So basically, when it's really concentrated, it's really corrosive, so it can burn. Like even if you breathe in the fumes, it can burn your lungs and so forth. So we don't want to be using, say, something like that in our high school lab. So we'll water it down so that you can still use it in your experiment, but not have the potential to hurt yourselves and so forth. All right. You need a 25 ml sample of concentrated sulfuric acid contains 44 grams of hydrogen sulfate. Calculate the amount concentration of the solution. So basically you need to, you're going to end up making 25 milliliters, and you're going to use 44 grams to make this solution. So we need to figure out, okay, so once we dump in this mass into 25 milliliters of water, mix it up, what's going to be the concentration? Okay, so let's start off with writing all the information that's given to us. Okay, so we have a volume. Okay, so if we go back, sorry, I went quickly through this formula here. So C is the amount concentration, N is still like the amount of moles, and V still is the volume of the solution. Okay, so I'm using V here, sulfuric acid. Okay, and but it's the whole sample too, so I can write sample, okay, so that we know that it's a mixture and so forth. Okay, so we have 25 milliliters, okay, and then we have a mass of hydrogen sulfate of 44 grams. Okay, so before we keep going here, remember how I said the volume has to be in liters, so we have to convert this into liters, and to do that you're going to divide by 1,000. Okay, so again, if you're looking at this later and wondering how we got to there, you just divide it by 1,000 here. Okay, because 1 milliliter or 1,000 milliliters is 1 liter. Okay, so from there, what do we need to find? It asks us for the amount concentration, which is the letter C. Oops. Okay, so we need to find the amount concentration, and here's our plan. So again, we're given the formula up here, C equals N over V. Okay, so in order to find concentration, we need the moles and divided by the volume. So we already have the volume, so it's good, but we don't have the amount in moles. So remember how in last unit to find amount, okay, we use this formula here. So it's back again. We're going to use it again. Okay, so we need to calculate moles first, and then we can use it in here to calculate the concentration. Okay, all right, so let's go through and actually put this plan into place. So we have the amount again of sulfuric acid is the masses. Again, the mass has to be in grams, and we're just, it doesn't say there, but that's what we did last unit. So just keep using that, because the when we have to use molar mass and so forth, molar mass is in grams per mole as well. Okay, so all right, so mass is in grams, that's okay, and we're going to divide by the molar mass of sulfuric acid here. So I'm just going to solve the molar mass. We're going to need that here. Okay, and again, our mass have to be in grams because we're going to be dividing here by the molar mass, which is in grams as well, but grams per mole. Okay, so that divided by 98.06 is 0.4485, etc. And just again, keep it in your calculator, okay? All right, so that's your amount in moles. And then in order to get the amount concentration, we're going to take, okay, this, take the amount in moles and then divide by the volume. Okay, and the volume has to be in liters. We've converted it, so we're going to make sure we use the liters value, and then we're going to divide, and we'll get 17.942, etc. And then it's mole per liter is the new unit that we're using for today's lesson, okay, mole per liter. So again, I'm going back and looking at the digits. I have 2 digits for mass, I have 3 digits for volume, so I'm going to get this down to 2 digits, so 18 mole per liter, okay? And then a lot of you are forgetting your therefore statement. Don't forget to write your therefore statement. Okay, so we had to find the amount concentration, so and then remember when you're handing in work to be marked, don't abbreviate anything, don't write half sentences and so forth, write the full sentence out, okay? The amount concentration of Okay, hydrogen sulfate, aqueous hydrogen sulfate, or sulfuric acid is 18 moles per liter. Example 1 again, but we're going to use the unit analysis method this time. So we have sulfuric acid. It was a concentrated stock solution brought from the supplier. And again, it's too dangerous, so we're going to water it down and make a 25 milliliter sample that contains 44 grams of hydrogen sulfate. Okay, so we need to find the amount concentration of this sample that we created. Okay, so we have 25 milliliters. Okay, we have to convert that to liters. We need to be working in liters when it comes to volume. And the mass is still grams. That's what we did before. I have the molar mass already in grams per mole. So we're going to go and find the amount concentration. So here is our plan slash solve step now. Okay. Okay, so step 1, you are trying to find the concentration. So I'm going to write C. Okay, you're finding the concentration of hydrogen sulfate. And so we're going to take our mass first. Okay, so we have our mass of hydrogen sulfate. And so we're trying to go from, so if you're taking a look at your formula sheet here now, we're trying to go from the mass to the moles to the concentration, okay? So anyway, we have to get from mass to moles island and then use volume in order to get to concentration here. So the first thing here, in order to go from mass to moles, is you need a molar mass. So you're going to take your molar mass, and again, you flip it, so the moles are up in the air of hydrogen sulfate, and you have the mass at the bottom, hydrogen sulfate. Okay, all right, I know you guys got used to, okay, the mole ratio has to go next. No, we don't have to do that here. So we are going to, we need to get to mole, so we need to get to mole per liter, and that's when we'll have concentration here, okay? So right now, so far what you've done is you've got the mass, you got rid of the mass, now you have moles, okay? So we're almost there, we just need the liters. So the other piece of information here in our given information here is the volume. So right now, if you decide, oh, I'm just going to put the volume right here. Okay, so if you do that, you end up with the units mole liter, which isn't what you want. You want mole per liter. So what you need to do here is you need to flip this down. Okay, so you need to have just like that, 1.025 liters. Okay, so you're just tweaking it so that you get a mole per liter answer. Okay, all right, so from there, this is what you need to do. You need to go 44 times 1 times 1, all divided by these two things here. Okay, and you end up with a concentration of 17.94, etc. Mole per liter. Okay, and again, we are just going to round to 2 digits. So we get to there, and then we write our therefore statement. Okay, all right, so yeah, so the unit analysis method is slightly different. You're still kind of going through getting to moles, right? So you're trying to go from mass to moles, and then this is the part where it gets a little bit tricky. So when you have to just go to concentration like this, then you're just going to kind of figure out where do I put volume in order to get a mole per liter unit, like that. Okay, so then we know, okay, I got to divide that last part by liters, and then I end up with mole per liter. Okay, right, on to example 2. Okay, so again, I'm going to use the formula method here for this one here. So I'm just going to go through, read through, and we're going to find all the information that's given. Okay, so household chlorine bleach is 0.067 mole per liter. So right away, you got to start recognizing things by the units. So mole per liter, you know that's concentration. Okay, and that's the sodium hypochlorite concentration. Okay, so bleach is a 0.067 mole per liter solution of sodium hypochlorite. All right, so what is the mass of hypochlorite in a volume of? So this is the bleach, this is like the sample, I guess, the whole thing. So you have a 225 milliliter sample, and you need to find the mass of sodium hypochlorite. Okay, so that's your goal. Okay, so again, I want you to, again, always check for this, change it, make sure it's in liters. So again, you're going to divide by 1,000, and you get to liters. Okay, all right, and then we have our mass that we need to find. Okay, so what's our plan here? Okay, so again, if you want to brainstorm, you're like, okay, I know this formula now, right? So that's concentration, that's volume, that's the amount. Okay, but then we can use, if once we find amount, we can get to using this formula, but we need to find the mass, right? So we're going to rearrange this. I'm going to boot this over here. Oops, sorry. This is molar mass, sorry. So boot the molar mass over here. So we get to there. So then we get the mass, right? So if we can find the amount from this one, that's what we're going to be doing here. So you need to boot this over, and then you get the amount this way. Okay, so step one, you're going to find the amount using this formula. And then step two, you're going to use your mass equals amount times the molar mass in order to get to the mass of the sodium hypochlorite. All right, but then one more thing here before we get started is that we need the molar mass of sodium hypochlorite. So we'll just do that right now. Okay, so again, remember, I will give you these formulas here. You just need to know when to rearrange them and so forth, okay? All right, so again, we need to get to mass. So in order to get to mass, we need to find the moles, amount to moles first, using the new concentration formula, amount concentration formula. And then once we found the amount, we're going to multiply by the molar mass, which I just found here, to get the mass of sodium hypochlorite. All right, so let's go through and start solving. So again, here's the amount of sodium hypochlorite. So we're going to take our concentration, and we're going to multiply by our volume. Okay, you see how the liters units will cancel out. Okay, and then we end up with the amount value of okay, and as usual, carry all the digits because this isn't your final answer. All right, and then now we're going to go to the second part. We're going to find the mass. Okay, and that's going to be the amount times the molar mass. Okay, so again, hopefully you kept it in your calculator, so then it's easy to calculate this out with all the digits. And so I'm just going to write out all the digits here that are on the calculator, and then see how moles and moles cancels out, so then you end up with gram. Here, a liter and liter canceled out. All right, so now we found the mass. I'm just going to figure out how much to round by here. So scroll back up. So I have, so again, the leading zeros don't count. So 1, 2 digits here. I have 3 digits here, so 2 digits. So let's just get this down to 1.1 grams. Okay, all right, let's make our therefore statement. Therefore, the mass, okay? So again, don't forget the key word. The mass of sodium hypochlorite is 1.1 grams. Is example 2 again. We're going to use the unit analysis method. So yeah, we don't need these formulas here. Yeah, and then we're going to use the little kind of reminder on the formula sheet on the back of the periodic table as well. Okay, so for us to go from, concentration volume information, we need to get to moles, and then we can get to the mass island here. Okay, so here's our plan and our solving step all at once. Okay, so we need to find the mass of sodium hypochlorite. Okay, so we have our concentration. Okay, and then I picked that one first because volumes, that one is the tricky one where you're not sure which way to put it. So I'm going to use the concentration because I eventually want to get to the mole island, right? So I want to have moles at the top, and then we can adjust the liters. So, so since we have the concentration mole per liter, now I can use the other value volume here. And again, where would I put it? I don't want to put it on the same level as the liters here, so I want to multiply it. So leave it at the top, like that. So if you want, you can put a 1 here. Right, so the liter and liter will cancel out. All right, so we can even just do that now here. Those will cancel out, so we're on the right track here. And then we want to get to mass. So we're going to use our molar mass now. So from here, we used our concentration of volume to get to moles. And now we're trying to get to the mass, so we're going to use molar mass. So that's kind of this little flow chart kind of helps with your thinking of what to do next and so forth. All right, so there we're going to put in our molar mass. So then we're deciding which way to put in our molar mass. So see how moles is at the bottom, but moles is at the top here. So we just put it in the way we see it. Okay, so again, this is sodium hypochlorite. This is sodium hypochlorite. Okay. All right, and this was the concentration of sodium hypochlorite as well. Okay, so from there, you'll see that the moles can also cancel out. Okay, those are gone, and so that leaves grams. Grams are left, liters are gone, the moles are gone, just the grams are left, and that's what we want for our mass here. So we're going to go through and we're going to calculate all the top values together, hit equals, and then divide by, oh, we don't even have to divide by anything, everything's 1 underneath. Okay, so we found our mass of sodium hypochlorite to be 1.83 grams. Okay, and we're going to round to 2 digits. Okay, for the mass. All right, make a therefore statement. Don't forget the keyword. I know a lot of you are tired after writing all this stuff, and then you're like, a lot of you just end up writing m equals 1.1. Okay, you have to be specific. Mass of hypochlorite, sodium hypochlorite, is 1.1 grams, like that. Okay, all right. Hopefully with those 2 examples, you feel confident now finding the concentration. If not, I can add some more here. Okay, so just go practice the worksheets and then try the checkpoint, okay? If you do need more practice, what I'm going to do today is I'm actually going to make a video of just how to get to the answers for the homework questions that I'm assigning today, okay? So if you are just needing a bit more practice, you can kind of work through the homework questions with the video and see if that helps. And if not, just please let me know, and I can also help you in person, over Google Meet and so forth, okay? All right, so again, either way, unit analysis method, formula, just be able to work through, by manipulating the formulas, using the old formula for the amount in order to calculate what the items that you need. Okay, so in the end, there'll be questions like find the concentration, amount concentration, or find the mass, which you're going to use the amount formula, or I might ask you to find the volume. So again, it's about rearranging this equation to get to what you need to find if you're going to use the formula method. And if you're using the unit analysis method, it's just about flipping things like using the molar mass. Again, like jumping between these islands and figuring out, okay, whenever I jump between these islands, I need to do something with the molar mass. When I'm going from moles to the volume island, I need concentration. So that's how you use this here. But I know sometimes you have to find concentration, so then you just take your amount and divide by your volume. But otherwise, if you're jumping between these islands here, from getting from moles or mass to moles to volume, you need to be using the item that's on the arrow here, okay?